Aloha! In this video I would like to discuss misconceptions and potential pitfalls of randomization. Random sampling and randomization are two essential components of experimentation. But the two concepts are easily confused. Random sampling refers to a method in which each member of a population has an independent chance of being selected, while randomization involves randomly assigning subjects to different groups, such as placebo and treatment groups. Despite their distinct roles, the similarity in their names often leads to confusion among students and even researchers. For instance, in a research handbook, the author advised against using random sampling in qualitative research, advocating instead for purposeful sampling as a more effective approach to achieve saturation. However, within the text, the terms randomization and random sampling were used interchangeably, illustrating a common misconception. Even well-established institutions can blur the distinction. As of January 30, 2025, the Department of Statistics at Yale University presented a misleading explanation of sampling in statistical inference on its website, stating that randomization is used in random sampling. By using randomization and random sampling interchangeably, the statement conflates two distinct concepts, potentially reinforcing misunderstandings among students and researchers. In summary, randomization pertains to the assignment of group membership after a sample has been drawn, whereas random sampling refers to the process of selecting subjects from a population. Recognizing this distinction is crucial for proper experimental design and statistical analysis. A quasi-experiment is a research design that lacks some of the necessary conditions for fully controlling the influence of extraneous variables, most notably random assignment. Very often it cannot be done due to ethical issues. In many cases, researchers are unable to randomly assign participants to different groups. For example, if the patients are very ill, assigning them to the placebo group is nothing more than a death sentence. Some limitations are natural. When studying gender differences in computer use, it is impossible to randomly assign gender. It is widely accepted that the primary distinction between experiments and quasi-experiments is the use of random assignment to group membership. However, some researchers also consider random selection as a distinguishing criterion. Quasi-experimental designs are a legitimate research approach, but researchers must be transparent with reviewers and readers when randomization is not fully implemented. A striking example of this issue occurred in 2013 when a groundbreaking study published in the New England Journal of Medicine suggested that adhering to a Mediterranean diet, MedDiet, could reduce the risk of heart attack, stroke, or death from cardiovascular disease by 30% compared to a low-fat diet. This study led to widespread recommendations in favor of the Mediterranean diet for general cardiovascular prevention. However, in 2018, the article was retracted after it was discovered that 14% of the participants, approximately 75,000 individuals, had not been randomly assigned. Specifically, many married couples were assigned to the same group, and in one extreme case, an entire village was placed in a single condition. Yet these flaws were not disclosed in the original publication. Despite this controversy, subsequent research has validated the health benefits of the Mediterranean diet. A 2019 study found strong evidence supporting its positive effects on cardiovascular health. Furthermore, a 2021 comprehensive review concluded that the Mediterranean diet is also associated with lower rates of diabetes and better glycemic control among diabetic patients. In some situations, full randomization of individuals is impractical. For example, when participants belong to the same household, as seen in the 2013 MedDiet study, it becomes difficult to assign family members to different groups. If one family member is placed in the control group while another is assigned to the treatment group, they may share information about their activities, thereby compromising the independence of responses. In such cases, alternative randomization strategies, such as cluster randomization, must be considered to preserve the validity of the research. Instead of randomizing individuals, researchers can randomize clusters, such as households, schools, or communities. In the example of households, rather than assigning individuals within a family to different groups, entire households can be assigned to either the control or treatment group. This prevents information spillover and maintains independent responses within the study. Indeed, the conclusion of the 2013 article, that the Mediterranean diet, MedDiet, offers significant health benefits, remains valid. What was invalid was the methodological approach used in the study. Had cluster randomization been implemented instead of flawed individual assignment, the paper would not have been retracted, and the researchers would have avoided public scrutiny and professional embarrassment. The situation is akin to an athlete being stripped of a gold medal due to a rule violation, despite their undeniable talent and performance. It is unfortunate, but in scientific research, as in sports, rules exist to ensure fairness and credibility, and they must be upheld. Let's look at another issue of randomization. When the sample size is small, simple randomization can lead to imbalances in demographic characteristics, such as one group having significantly more females than males. This imbalance can introduce confounding variables and affect the validity of the study. In such cases, matched pair design or matched paired randomization techniques can be used to ensure balance. In this method, participants are first paired based on similar attributes, such as age, gender, baseline health status, or other relevant variables that could influence the study outcome. Once the pairs are formed, one participant from each pair is randomly assigned to the treatment group, while the other is placed in the control group. This approach minimizes confounding variables by ensuring that both groups are as comparable as possible before the intervention, thereby increasing the internal validity of the study. Matched pair randomization is particularly useful in clinical trials, psychological research, and other studies where demographic or baseline imbalances could skew the results. Compared to simple randomization, this method provides greater control over group composition, making it an effective strategy for studies with limited sample sizes. I hope this video can disentangle the confusion between random sampling and randomization, while also highlighting the potential pitfalls of simple randomization. Thank you for watching.